Imagine standing on a quiet stretch of coastline today. And 10 years from now, that same shoreline has transformed into one of the busiest gateways on Earth. Giant container ships tower above the waves like floating skyscrapers. Cranes move with astonishing precision, and millions of tons of cargo flow through a place that barely existed before. But here's what nobody tells you. Before a single ship can dock, engineers must reshape the land itself. Today, we're going behind the scenes of the world's most ambitious port expansion projects to uncover how humans build entire cities for the sea. Think about this. Some of today's largest port expansion projects move more earth than the construction of entire megacities. Engineers relocate mountains, dredge millions of cubic meters of seabed, pour enough concrete to build thousands of skyscrapers, and create brand new land where only deep ocean existed before. Every centimeter must withstand crushing waves, powerful tides, and the weight of ships carrying more than 24,000 containers. And this is where the story becomes truly extraordinary. Most people see a finished port. They never see the hidden journey that begins years earlier inside mines, quarries, steel mills, cement plants, and shipyards spread across several continents. Every breakwater, quay wall, crane rail, and container yard starts as raw materials buried deep beneath the Earth's surface. What happens next surprised even experienced engineers, because the real challenge isn't building a port, it's building the ground. Every giant port expansion begins with rock, an unbelievable amount of it. Engineers often use granite or basalt because these stones resist erosion and survive decades of relentless wave impacts. Massive quarries in Norway, India, China, Australia, and Brazil blast solid mountains into blocks weighing anywhere from 5 to 30 tons each. The sound of controlled explosions echoes through the valleys before enormous excavators begin loading these giant stones onto heavy-haul trucks. Those rocks travel an incredible journey before they ever touch the ocean. Heavy freight trains haul thousands of tons to coastal terminals, where specialized barges transport them hundreds or even thousands of kilometers to the construction site. A single large breakwater may consume more than 10 million tons of armor rock, enough to fill nearly 4,000 Olympic swimming pools. Most people never imagine that the first building material of a port isn't steel. It's an entire mountain. Think about this. Every piece of steel receives its own digital identity before the first cut even begins. Engineers load three-dimensional CAD models directly into the CNC system, and precision servo motors guide the cutting head at speeds of 2 to 6 meters per minute, adjusting automatically as the steel thickness changes. Laser positioning systems verify alignment within plus or minus 0.2 millimeters, because even a tiny error here could multiply into centimeters by the time the boom reaches over 100 meters into the sky. Most people never think about this, but a crane's future lifting power starts with invisible digital measurements. That cement mixes with carefully graded sand, crushed stone, water, and chemical admixtures to create marine-grade concrete capable of surviving decades in corrosive saltwater. Engineers often design these mixes to reach compressive strengths exceeding 50 megapascals. Every batch must balance durability, workability, and resistance to chloride penetration, because one hidden crack can shorten the life of an entire terminal. You can almost smell the fresh cement as giant mixers churn day and night. Steel forms the skeleton of every modern port. Iron ore from Australia's Pilbara region and Brazil's Carajás mines combines with metallurgical coal to create structural steel used for crane rails, quay walls, reinforcement cages, and towering cargo cranes. Blast furnaces operate above 1,500 degrees Celsius, producing molten metal that pours like glowing rivers before it cools into beams weighing several tons each. The thunder of rolling mills never stops. But here's a secret hidden beneath many modern ports. Engineers often pump millions of cubic meters of sand from the seabed to create entirely new land through reclamation. Specialized trailing suction hopper dredgers vacuum sediment from carefully approved offshore borrow areas before pumping it through floating pipelines onto the future terminal. Laser-guided bulldozers then spread each layer with remarkable precision until the new coastline slowly rises above the sea. Of course, building bigger ports also carries enormous environmental responsibility. Construction teams monitor water quality, protect nearby coral reefs and mangroves, reduce underwater noise, and install silt curtains to prevent sediment from spreading into sensitive ecosystems. Some projects even create new wetlands and artificial reefs after construction finishes, proving that modern engineering increasingly works alongside nature instead of against it. Yet one massive challenge still remains. Because gathering the raw materials only begins the adventure. In the next stage, thousands of workers and some of the largest construction machines ever built will race against tides, storms, and unforgiving deadlines to assemble an entire deep-water port piece by piece. And what happens when ships arrive before the harbor is even finished? Changes everything. The moment the raw materials arrive, the coastline becomes one of the busiest construction sites on Earth. Hundreds of machines move in perfect coordination, guided by GPS satellites accurate to within just a few centimeters. Before anyone can build upward, engineers must build downward, strengthening the ground hidden beneath the sea. Imagine trying to construct a skyscraper on wet sand. That's exactly the challenge they face. The first operation begins with dredging. Giant cutter suction dredgers rotate steel cutting heads at around 30 to 40 revolutions per minute, breaking apart compacted seabed while powerful pumps move nearly 6,000 cubic meters of sand every hour through floating pipelines. You hear the deep rumble of diesel engines, the hiss of high-pressure slurry, and the constant splash of seawater as millions of tons of material flow toward the new shoreline. The salty air mixes with the smell of wet earth pulled from the ocean floor. KS-like destruction actually creates one of the strongest foundations ever built. Freshly reclaimed ground cannot support cranes weighing thousands of tons, so engineers strengthen it using vertical drains and dynamic compaction. Steel weights weighing up to 25 tons drop from heights of nearly 25 meters, slamming into the ground again and again to squeeze water from the soil. Each impact sends vibrations racing through the earth like a miniature earthquake. Walloo. Now comes one of the most spectacular stages, building the breakwater. Floating cranes capable of lifting more than 5,000 tons carefully place giant armor rocks one by one. Some concrete armor units weigh over 100 tons each, locking together like an enormous three-dimensional puzzle. Every placement takes only a few minutes, but engineers check each position with remarkable precision because a single misplaced block can weaken the entire structure. Next, specialized piling rigs begin driving steel tubular piles deep beneath the future quay wall. Hydraulic hammers deliver thousands of powerful blows, generating impact forces measured in hundreds of tons until each pile reaches stable ground. Every strike echoes across the harbor like rolling thunder. Sparks flash, steel vibrates, and the entire shoreline seems to shake with every impact. With the foundation complete, workers assemble enormous reinforcement cages before pouring marine-grade concrete into massive forms. Concrete arrives fresh from batching plants and must be placed within about 90 minutes to maintain quality. Powerful pumps deliver it under pressures exceeding 80 bar, filling every corner before internal vibrators remove trapped air. The smell of fresh cement fills the air while smooth gray walls slowly emerge from the forms. Concrete may look solid after a day, but the real transformation happens quietly. During curing, cement reacts chemically with water in a process called hydration, generating heat while microscopic crystals grow stronger hour after hour. Engineers carefully monitor temperature because excessive heat can create hidden cracks deep inside the structure. Sometimes the concrete actually feels warm beneath your hand even hours after pouring. Once the quay reaches full strength, crews install crane rails with astonishing precision. Laser instruments align every section within plus or minus 2 millimeters across hundreds of meters. Surveyors work patiently under the blazing sun, because even the smallest error could cause cranes weighing nearly 2,000 tons to drift off alignment. It's a level of accuracy you would expect inside a watch factory, not on the edge of the ocean. Now the giants finally arrive. Ship-to-shore cranes, standing more than 140 meters tall, arrive in enormous sections aboard heavy-lift vessels. Floating cranes lift each module into position while crews tighten thousands of high-strength bolts with hydraulic torque tools operating at pressures above 700 bar. Steel groans softly as each piece locks into place, and slowly the world's most recognizable port machines rise into the sky. Finally, engineers pave container yards stretching for hundreds of hectares. High-capacity asphalt pavers lay smooth surfaces while rollers weighing more than 15 tons compact each layer until it reaches the required density. Utility crews install power cables, fiber optic networks, drainage systems, and automated lighting beneath the surface before the final markings appear. What looked like an empty shoreline only months ago now resembles a futuristic city built entirely for global trade. But construction isn't finished just because every structure stands in place. Before a single container moves through the terminal, every crane, rail, sensor, cable, and foundation must survive some of the toughest engineering tests on Earth. And that's where human skill meets cutting-edge technology in ways few people ever get to witness. The construction crews may leave, but a new team now takes over. Before this port can welcome its first cargo ship, every system must prove it can perform flawlessly around the clock. Think about this. One tiny sensor failure or a rail that's just a few millimeters out of position could delay thousands of containers worth millions of dollars. This is where engineering becomes an exact science. Every crane begins with an electronic nervous system. Thousands of sensors monitor motor temperatures, gearbox vibrations, wind speed, cable tension, wheel alignment, and structural movement in real time. Fiber optic networks transmit this information to control rooms in milliseconds, where artificial intelligence searches for patterns long before human could notice a problem. Most people see a crane. Engineers see a living machine that constantly talks to itself. Laser scanners now measure every critical surface with astonishing precision. Rotating laser heads create millions of measurement points every second, checking crane rails, quay walls, and pavement elevations to tolerances as tight as plus or minus 2 millimeters. Green laser beams sweep silently across steel and concrete while digital models instantly compare reality against the original engineering design. Even the smallest imperfection has nowhere to hide. But seeing isn't enough. Engineers also look deep inside the concrete without breaking it apart. Ground-penetrating radar, ultrasonic testing, and acoustic sensors search for hidden voids, cracks, or weak bonding beneath the surface. Invisible sound waves travel through the massive structures and return with clues about their internal condition. It's almost like giving an entire harbor a full-body medical scan. Now comes one of the most dramatic moments of the entire project: the crane load test. Engineers suspend enormous steel weights that can exceed 125% of the crane's rated lifting capacity, pushing the structure beyond its normal operating limits. Hydraulic systems, strain gauges, and laser instruments monitor every movement while the steel framework bends by only tiny fractions of a millimeter. The entire harbor falls silent as thousands of tons hang suspended high above the ground. Wind creates another hidden challenge. Computer-controlled systems simulate storm conditions while anemometers measure gusts approaching 70 kilometers per hour, or about 43 miles per hour. Automated brakes engage instantly, locking wheels against the rails before powerful winds can move the crane even a few centimeters. What looks effortless during normal operation actually depends on thousands of perfectly timed calculations every second. The terminal's automation system undergoes its own intense examination. Automated guided vehicles drive predetermined routes using GPS, LiDAR, radar, and onboard cameras while AI software coordinates every movement to prevent collisions. Hundreds of simulated containers travel across the yard before a real shipment ever arrives. Watching dozens of driverless vehicles glide silently through the terminal feels like stepping into the future. Quality inspectors never rely on machines alone. Experienced engineers walk every meter of the quay, listening for unusual sounds, checking welds by hand, and spotting subtle imperfections that software sometimes overlooks. Years of experience allow them to notice tiny changes in color, texture, or vibration that no algorithm can fully understand. In this moment, human instinct still beats artificial intelligence. Only after passing every inspection can the machine earn international quality certifications and receive final software calibration. Engineers upload the latest operating algorithms, verify satellite communication, and record every measurement in a permanent digital history file. From that moment forward, the tractor carries a manufacturing fingerprint that technicians can trace years into the future. Every bolt, every sensor, and every software version becomes part of its story. Finally, the moment of truth arrives. A fully loaded container ship approaches the brand new berth, tugboats guide it into position, and the giant cranes spring to life for the very first time. Every motor hums, every sensor responds, and every container lands exactly where it should. Yet beyond this spectacular first operation lies an even bigger story: the incredible global race to build the ports of tomorrow. Now step back and look at the bigger picture. More than 80% of global merchandise trade by volume travels by sea, and nearly every one of those goods passes through a port at least once before reaching its destination. Without constant port expansion, the world's supply chains would quickly become overwhelmed as ships grow larger and international trade continues to increase. Most people never think about this, but every smartphone, refrigerator, bicycle, and coffee maker has likely passed through a modern seaport. Port expansion has become one of the largest infrastructure industries on Earth. The global market for port construction, expansion, modernization, and related infrastructure reaches hundreds of billions of US dollars when ongoing megaprojects are combined. Every year, billions of tons of rock, concrete, steel, and reclaimed sand become new terminals, deeper channels, and stronger breakwaters. Imagine building an entirely new industrial city almost every single year. That gives you an idea of the scale. Today, China leads the world in port construction and cargo handling capacity, followed by countries including Singapore, the Netherlands, South Korea, and the United Arab Emirates, each investing heavily in larger terminals and smarter logistics networks. Together, these nations handle a remarkable share of the world's container traffic, while continually expanding to accommodate even larger ships. Competition never stops because every hour saved in a port can save shipping companies millions of dollars each year. Behind every successful port stands an enormous global workforce. Millions of people contribute directly or indirectly. From quarry workers, steelmakers, cement producers, dredging crews, marine engineers, surveyors, crane operators, electricians, software developers, and environmental scientists to logistics specialists who coordinate cargo around the clock. A single large expansion project can employ tens of thousands of workers over several years. It's one of the greatest examples of international teamwork in modern engineering. The history of port expansion stretches back thousands of years, but today's engineering revolution began only about 50 years ago. As container shipping transformed global trade, ports evolved from simple docks into highly automated logistics hubs stretching across hundreds or even thousands of hectares. Ships grew from carrying a few thousand containers to more than 24,000 TEUs, forcing engineers to rethink almost every aspect of port design. Every generation built bigger than the last. The next decade promises an even bigger transformation. Artificial intelligence will optimize ship arrivals before vessels even reach the harbor. Autonomous electric trucks, remotely operated cranes, hydrogen-powered equipment, digital twins, and predictive maintenance systems will reduce delays while cutting emissions dramatically. The ports of tomorrow won't just move cargo faster, they'll think, learn, and continuously improve every hour of every day. Before we finish, here are 3 incredible facts that almost sound impossible. Did you know some modern dredgers can move enough sand in a single day to fill hundreds of Olympic swimming pools? Did you know the tallest ship-to-shore cranes rise higher than many 40-story buildings? And did you know engineers sometimes create entire islands from reclaimed land before building a single warehouse or container yard? What once seemed impossible has become routine through human determination and engineering brilliance. So the next time you see a container ship disappear beyond the horizon, remember what lies beneath the waves and beneath the concrete. Hidden below every modern terminal are millions of tons of carefully placed rock, precision-engineered steel, marine-grade concrete, advanced sensors, and decades of engineering knowledge working together every second of every day. These remarkable projects don't simply expand coastlines, they expand the possibilities of global trade, connecting continents and bringing the world closer together. And perhaps the greatest achievement isn't the size of these ports, but the imagination that made them possible. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.